Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. In this episode, we look at the Car2TERA project once again. Car2TERA is an EU-funded effort to push forward the technologies associated with autonomous driving. One such technology is the use of a relatively new material called graphene. Our guest today is an expert on graphene. He brings years of experience to Car2TERA in hopes of finding less expensive and more efficient technologies to develop in-car radar and onboard communication systems in the eventual self-driving automobile. I'm your host, Peter Ballant from Technicon, and today we welcome Wlodek Strupinski, who spoke with us from his home office in Poland. He represents project partner Vigo System, assessing graphene as an alternative technology to silicone. Let's start out by first asking the broad question, what is the overall aim of the Car2TERA project?
Okay, so due to autonomous automobiles are very fast and developing, there is the need of for a next generation smart automotive electronic systems, and Car2TERA proposes new radars for in-cabin sensing, which is a step forward in the range of car driving safety. So the aim of the Car2TERA project is to increase safety for car drivers, constructing and exploring of use of new sub-terahertz radars for in-cabin application, as well as high-speed data communication on board in cabin. So this is a general aim of the project, and my contribution is within application of emerging technologies of two-dimensional material as graphene.
Graphene, you're working with graphene. This sounds kind of like a miracle semiconductor. Is that right?
This is miracle material, but the semiconductor is not as good as we would like. Graphene, due to a very narrow band gap, is not a typical semiconductor. So, but we try to apply other very attractive properties of graphene. So this ultra high linearity and large bandwidth may create graphene devices, which could compete with the existing conventional systems.
And so normally for these constructions of these circuits, silicone would be used. But what advantages do you have with graphene then? Is it size? Is it cost? Is it conductivity or
performance? So thanks to this ultra high linearity and large bandwidth, it's possible to compete with the existing technology in high frequency applications.
Okay, and you say this is a new technology. It's still perhaps in development. Is there anywhere currently where graphene is being used?
Well, graphene technologies have been developed since almost 10 years, mostly in Europe. It's a very hot topic all over the world in many universities, research centers, and also private industrial commercial companies are interested in development of graphene technology and applications. So in many different fields of industry, like energy applications. So graphene is used for batteries, for supercapacitors, in photovoltaics, for lower IT, for optoelectronic devices, where we need devices for communications, sensors, also multifunctional composites in aviation, automotive construction or micro constructions. Graphene is applied in environmental technologies, for instance, for water purification or desalination, for filtering, self-cleaning surfaces, We most focus on electronic applications, biomedical technologies, sensors, detectors. I can say that graphene-based technologies are now reaching the tipping point for mass exploitation. So this is a very good chance for Europe. We should also remember that graphene was the first two-dimensional material discovered, but now we know that there are about 1,800 of two-dimensional different forms. So there is really a large choice for further 2D technology development. So not only graphene, but a combination of graphene or other 2D materials, we really can construct many different and new material systems with new parameters, which could be applied in many different fields.
It's a whole new frontier, really, and it's exciting that Car2TERA could contribute in some way.
Yeah.
For you personally, and for your company, perhaps Vigo, what does success look like in Car2TERA?
Vigo System company is a producer of infrared detectors devices, but Vigo System also produce materials using MOCVD epitaxy for these photodetectors, and now extended their activity by epitaxy of 5 semiconductor compounds, and also has some experience and tradition in graphene photodetectors. So everything around devices now is also focusing on VCSEL lasers. So Vigo System is one of the most innovative company in Poland, is also interested in graphene devices. So if having human resources and infrastructure for production of both materials and devices. So in this case, Vigo is interested in production of materials, graphene on silicon carbide. And if such material would be applied in applications such as next generation car radars, it would be very good business for Vigo.
Right. How is it working with partners who are not in the office next door, but they're in another country across Europe?
Well, we've been collaborating with Chalmers for many years. We developed kind of collaboration. We meet time to time. We contact by using any form of communications. So it's this is quite easy, and everyone knows their role in the project. So we are responsible for technology and material providing. Chalmers for fabrication devices. We exchange with the results, discussing, planning the next experiment. So everything is going very smoothly.
That's great to hear. Is there anything else you wanted us to know about the Car2TERA project?
Yeah. So first of all, I think this development and the results of very extended research work we did within a graphene flagship project now could be commercialized and verified by very demanding application in sub-terahertz radars. So this is very interesting and very attractive moment that after several years of research on graphene, we tried to produce one of the most advanced electronic systems using graphene. So first of all, this is very excited for scientists, for engineers, but in the same time, it's very attractive from a commercialization point of view. So if we succeed, and I think we succeed in this topic, so this is also a very good chance for European companies like our Vigo System company, and also for other partners of the consortium, for universities to continue this graphene material application in real devices. So this is, I think, the most important message we could take home concerning this graphene part of Car2TERA project.
Well, thank you very much for talking with us today about Car2TERA. It's an interesting project, and you have an interesting part in the project, working with some really high-tech stuff that is promising to not only deliver technology results, but also to deliver safety results. And on behalf of Technicon, I say thanks for doing that. Thanks for pushing the project forward, and thanks for all you do in science.
Thank you.
For more information about this project, go to Car2TERA.eu. This podcast has been brought to you by Technicon. The Car2TERA project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 824962.